Hello students, I am Ms. Renita Pinto, Assistant Professor from the Department of ECE, SMVITM College. Today we will be discussing about the EMF equation of DC generator. So before going to the EMF equation of DC generator, let us first see what are the two types of armature winding. Now why we are going to this, because the EMF equation will also depend upon the type of armature winding. That is, depending upon the armature winding, EMF equation will change. So there are two types of armature windings. One is the lap winding, another one is the wave winding. In the lap winding, if you see, the winding will start from the first slot, from the first conductor. It keeps on overlapping until the starting point is reached again. Now here what happens is, the number of parallel paths A will be equal to number of poles P. So number of parallel paths A is equal to number of poles P. If we go to the wave winding, if you see here, you can see the winding will progress in a wave fashion. Therefore it is called as wave winding. So if you see here, the winding starts from two different slots here. It will keep on going without overlapping each other. So here in this case, the number of parallel paths A is equal to 2. So you need to remember this during the derivation. So let us go to the main topic, EMF equation of DC generator. So let me take phi as the flux per pole and Z as the total number of armature conductors. Now we already know, in order to get a larger output, we need to connect Z number of conductors in series. So totally there are Z number of conductors here. We have P number of poles, A number of parallel paths, N as the rotation in revolutions per minute. So remember this, N is the number of revolutions per minute in RPM. E is the EMF generated. Now, according to the Faraday's law of electromagnetic induction, you already know, according to this, EMF can be given by d phi by dt. So E is equal to d phi by dt. Now, first we need to find out what is this d phi, what is this dt. Let us first go to find out what is d phi. Now d phi is nothing but the flux cut by the conductor in one revolution. So if I consider one revolution, you already know that there are p number of poles and there is phi flux which is there present. Now in the one revolution, what happens? P number of poles will go through phi amount of flux once. Therefore I can also write d phi as P into phi. Next, let me find out what is the number of revolutions per second. So we have already considered N as the number of revolutions per minute. That is, for 1 minute you have N number of revolutions. So I can also take this as 60 seconds. Next, I need to find out what is the number of revolutions per second. Per second in the sense, for 1 second, how many number of revolutions do you have? So according to this, I will get N by 60. So N by 60 is the number of revolutions per second. Now, let me find out what is the time for one revolution. That is dt. So, time for one revolution. How can you find out that? Let me go through this same thing again. So, you have n number of revolutions in 60 seconds. So you need to find out what is the time for one revolution in second. So according to this, you have 60 by n seconds. So this is how you are going to get dt. So you have E is equal to d phi by dt. If you substitute this in the place of dt, 60 by n, then what will you get? You will get p phi n by 60. So this is how we are going to get EMF generated for the DC generator. So you need to remember this. EMF generated is equal to phi p nz by 60A. Now let me consider this. Now according to this, I have already told you the EMF equation will differ depending upon the windings. So let us find out what is it. So we have phi p nz by 60A as the EMF. Phi p n z by 60A. So I've already told you we have two types of armature windings, that is, one is wave wound, other one is lap wound. Now in the wave wound you have already seen what happens. The number of parallel paths A will be equal to 2. So let me substitute A equal to 2 in this above equation. What happens? You will get phi p n z divided by 120 as the EMF generated for wave wound generator. So this is your equation for wave wound generator. Let me go back to the lap wound generator. In the lap wound generator, what happens? You have got a number of parallel paths. For your a number of parallel paths, you have a is equal to p. For lap wound generator, we have a equal to p. That is, number of parallel paths is equal to number of poles. So substituting a equal to p in the above equation, we will get phi p n z divided by 60. So instead of a, you have to substitute p here. So what happens? P and p cancels. So you will be left out with phi n z divided by 60. So this is the equation for lap wound generator. So this is how we find out the EMF equation of DC generator. Thank you.